What's going on, you guys? Mr. Allen here. We are about to classify this dope triangle ABC here, by sides and by angles on this XY coordinate plane. Oh my goodness, this is going to be so much fun. All right, so basically I need to get my sides here, at least to start. Okay, I got to get my side lengths. Now we do get a freebie here, okay? AB right here, I can just count that one out. Notice how my X coordinate is -2 and -2. So that's the same, it's a vertical line. I can just count 1, 2, 3, 4, 5, 6, or just find the difference between 4 and -2. So I know this one is 6. Yay! One of them is done. Now next here, what I have to do is I actually have to use distance formula to figure these other ones out. Okay, I'm going to do a little bit of the work up here. So for AC here, I'm going to have the square root of, then I'm going to have x2 minus x1 squared, so 5 minus -2 squared. 5 minus -2 squared plus, and then I have -1 minus 4 squared. -1 minus, oops, not a comma, minus 4 squared. All right, so 5 minus -2, that's going to be 7, positive 7. So let's keep the square root going here. So I'm going to have 7 squared plus, here I'm going to have -1 minus 4, that's -5. I'll keep that in parentheses here. Always a wise move. Beautiful. So 7 squared is 49. And -5 squared is 25. Okay, so what's 49 plus 25? 40 plus 20, that's 60. Then we got 14, there's 74. Okay, so my square root of 74, that's AC. I'm just going to jot that down here. Square root of 74. Now normally, we'd be required to reduce this thing, a little factor tree action. But it doesn't ask us for the side lengths. It asks us to classify by sides. And honestly, it's easier if you leave it as an unsimplified radical. Trust me on that one. Okay. BC. All right. BC time. Now, if your teacher says you have to simplify it, then you have to listen to them. But you're always welcome to be like, well, dude, Mr. Allen Math, he said it's better not to. You should go fight him. Don't actually say that. Okay. Anywho, square root. Okay. Now I'm taking B and C. And it really doesn't matter which one I start with, but I got to start with my x's. 5 minus -2. Make sure you pair your x's together. So 5 minus -2. That sounds familiar. Oh, that's right, because we just did that. And then plus, and then we've got -1 minus -2. -1 minus -2. Cool. Squared. Don't forget that. All right. You might be wondering, like, why can't I just, like, get rid of the squareds and the square root? Because there's addition there, okay? The addition doesn't allow us to simplify like that. Okay, so I know this one's going to be 7 squared, right? Just like last time. Ain't gonna change. And then I got, that becomes positive, so -1 plus 2, that's +1 squared. So now I have 49 plus 1 in the square root. That's going to be the square root of 50. And I'm going to leave that as the square root of 50. Okay. I could simplify it. It'd be, what, 5 root 2? No point in doing that for this particular problem. So here we know this is not neither of these is a perfect square that's going to give me 6, right? All three of these sides are different. So for number 1 here by sides, it is scalene. Scalene. Okay, scalene. Scalene. I think that's is that a Bob Dylan song? No, it's Jolene. All right. You guys probably don't know that in high school. I shouldn't make those kinds of... That's an old song. All right. It's older than me. It's older than me, man. Okay. Anywho, now by angles. This one's a little bit more work. I'm actually going to switch colors here because, this blue looks too much like the white here. All right. So for this one here, all right, for this one, I'm actually using the Pythagorean converse. My boy, Pythag, right? Now, I like to start with my C squared, and then I figure out if A squared plus B squared is either less, more, equal. We'll see. All right. So which one is my biggest side? Right? It's not always safe to eyeball these things. But the square root of 50, right, that's a little more than the square root of 49. I know the square root of 49 is 7, so that's going to be bigger than this guy here. And then square root of 74 is obviously bigger than the square root of 50. So actually, AC is going to be my largest size. I like to look at, like, what's the closest thing? Well, it's between, 64 and 81, which are perfect squares. So this is non-calc. We can do this, right? This is going to be between 8 and 9, okay? Largest side right there. So then I'm going to start with the square root of 74 squared. I like to leave a little box here. Like, I don't know, is that going to be larger than, smaller than, is going to be equal to? I don't know. Question mark, right? We can also throw a question mark if you really want. And then I can do these two. Doesn't matter the order. So I'll have the square root of 50 squared plus 6 squared. So now you might be seeing why it was advantageous to leave these square roots unsimplified, because now the square roots just cancel, right? Pew, 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 pew. Got to do the sound effects, okay? So now I have 74. I'll scooch over a little bit. 74, box with a question mark. I don't know. Is then we got 50 plus, what, 36? So I've got 86 here, and I got 74. So I know that 74 is less than 86, which means that this has to be acute. All right, and this is why I like to do the c squared first, okay? I do the c squared first because then the inequality like makes sense to me in my brain. And hopefully your brain makes sense like my brain makes sense, right? So that we're all making sense together. If I say 74 is less than, I think small, I think acute. If this number were larger, and I said 74 is greater than something else, right? Greater than makes me think obtuse. And then if it's equal to, it's right. But for this one, 74 is less than the 86, therefore it's acute. All three sides were different, so it's scalene. If two of the sides are the same, it's isosceles. If they're all the same, it's equilateral. There we go, man. Kind of a beefy problem, man, when you got to support all this stuff, but hopefully you guys grasped it all, and felt pretty wonderful about it, right? Love me some Pythag. See you dogs later.